Okay, hey, I wanted to send this out. Just got a few questions on the 12.1, 12.2a worksheet, particularly with number 6. That is a gigantic angle, the 32,589. The question I'm getting is, are you wanting us, when we draw this, to draw like a zillion of those circles all around there? And the answer is no, because this is going to rotate around many times, okay? So you don't have to worry about drawing all of those like 360-degree circles every time there's a rotation when the angle is this huge, okay? Also, I will tell you that we know that you need to keep subtracting 360 degrees until you get this number whittled down to a number where you can figure out how you're supposed to sketch this. Do not, on your calculator, subtract 360 and then hit enter, and subtract 360 and then hit enter. It's going to take you a really long time. Okay. Instead, what you want to do on your calculator is figure out how many times 360 will divide into 32,589. And if you divide that on your calculator, you're going to see on your screen, it does not go in there evenly, but it goes in 90.525 times. Okay, so what that tells us is it tells us that 360 definitely goes into 32,589 a full 90 times. So I'm going to see what that is. If I multiply 360 times 90, it goes in there 32,400 times. Okay, so that means that you would have made 32,400 loops if you were drawing those, which we are not going to do. Okay, and I need to just figure out what's left here. Okay, when I do this subtraction, this is what I'm really after. I want to see, okay, here's the angle. This is the coterminal angle that I'm really trying to sketch here. Okay, so I'm going to sketch the initial side here. Okay, one positive coterminal angle, and then it's asking for one negative, but 186. Now that's an angle that I feel like I could definitely sketch here. I'm going to go positive, so that's going counterclockwise. Okay, when I travel to here, that's 180, so I just need to go just a smidge more so that I've traveled 186 degrees. Okay, and then to get the negative version of that, we simply could take 186 and subtract 360 from 186, and that would give us negative 174. That would be the negative version. Okay, so on that blank, when it's asking you for the coterminal angles, positive 186 and negative 174 be the same two angles. That would just be going like this other direction, 174 degrees. But you do not need to draw like all those Twilight Zone spirals there for this. Okay. Okay, the other question is just more in how to get these pictures sketched for numbers 20 and 21. One thing that you may have overlooked is that for 20 and 21, they both share the same directions at the top that's bolded. It mentions this pilot is flying at an altitude of 8.5 miles, and that's really important to the picture that you're going to draw. So I'm just going to help you set the picture up, and hopefully that'll be enough of a push that you guys can follow through with answering the question then. It says in 20, if the pilot begins descending 300 horizontal miles from the airport, okay? So again, forgive this horrible artwork here, but here's the airplane. Okay, let's pretend right here where the star is where the airplane is wanting to land to kind of hit the runway there. Okay, so again, back up to the directions. This was all the way bolded above 20 and 21. It says that the airplane pilot is 8.5 miles. That's what his altitude is. So I'm going to label that vertical distance 8.5 miles. Okay, then down in problem number 20, you're going to see it says if he begins descending 300, the key word here is 300 horizontal miles from the airport. So the 300 horizontal miles is not the hypotenuse. That would be if the plane dropped straight down out of the sky, this distance along the ground is 300. Okay, now here's what the question is asking. The question wants to know what angle with the plane's path will the oh, that's like worded weird. What angle will, I think it should be will, the plane's path make with the runway without any further adjustment? So it is asking for this angle of depression right in here. Okay, that's what the question's asking for. Hopefully with that picture, that's enough of a push that you guys can finish off figuring out how to solve for that angle. Okay, in 21, similar scenario here. Again, we have this horrible airplane. Wow, that's really bad. Okay. And we're still sticking with the fact that that airplane is 8.5 miles altitude there. But the question in 21 is, for the comfort of the passengers, the maximum angle of depression when you're initially tilting that nose of the plane down is 5 degrees. Okay, so that's the most that a pilot should be tilting the nose of the plane down. Now remember, technically that's this angle out here, but we know that even with angles of depression, angles of elevation, they're both technically inside the triangle at the bottom. We talked about those being alternate interior angles in a previous lesson. Okay, so we're going to say that if that airline pilot tilts the nose of the plane down 5 degrees, so I'm going to fill that in here. I actually know that angle is going to be 5 degrees. I'm going to scratch that off there. That's 5 degrees. The question is, at what distance, and notice it says in parentheses there, as measured along the ground, so this is talking about that horizontal distance, should the pilot begin his descent? And so in 21, we are trying to solve for that side that's labeled X, and in 20, we are trying to solve for the angle right there. Okay, hopefully this is helpful to you. Just reach out if you guys have more questions. I'm happy to make short videos like this or try to answer your question if I can through an email or something. Okay,